Hi everyone and welcome to the Gateways web series for educators. My name is Jesse, and for those of you who don't know, Gateways is an organisation that provides educational workshops for gifted and talented students. We take scientists, engineers, authors, artists and educators, and we put them in front of gifted and talented students to run exciting and really interesting educational workshops. Now, I'm a program coordinator for Gateways, and that means that I get to work with these people to develop those workshops. And one of those people is Sanjin, and Sanjin joins me today. And Sanjin, do you want to share with us who you are and what you do?
Sure. So I did robotics at ANU, and that was the beginning of my professional life back, 2003 to 2007. After working in the industry for 5 years, mostly in mining, I decided I just wanted something different. So to get out of the office and into the classroom. So at the time, there wasn't really that much happening in the digital technology space in schools. So I actually picked, what did I pick? Math and physics as methods. And I was looking for something to do with microcontrollers. So like small programmable computers, if that was like the start of the maker movement. And I ran into the daughter of one of the directors of Gateways, and I started doing Gateways programs pretty much at the same time I started teaching. And that was about 9 years ago. So yeah, since then, Gateways has been a playground for me, like a place to experiment, try brand new things. And it started off like with robotics and microcontrollers. And now it's all about games and game development. And that's what we're going to talk about a bit more today.
Yeah, because we were discussing how cool it would be to be a fly on the wall in some of these Gateways programs. And you're going to share with me today one of the programs that you've been working on and perhaps what the students have been doing, because my background's in science, it's not in coding. So I'm really interested to hear what you've been doing.
Sure. Let me screen share here. So here it is, 3D game design with Python and Ursina Engine. So first of all, let's break this down. Python's like the second most popular programming language in the world after JavaScript, and it's probably going to be the most popular. It's designed, with beginners in mind. Like if you know the concept of Esperanto, which was like the language UN wanted to come up with that everybody could learn very easily, like a super basic language, that's Python for programmers. The idea was that programmers who program in different languages could all learn Python, and then they could communicate with each other and collaborate more productively, right? Now, Python's taken off in the domain of like data science, machine learning, artificial intelligence, as well as some back-end web development stuff, like databases that are behind websites. But when it comes to games, really, it hasn't been popular at all. And there's a bunch of nerds out there that are coming up with cool new ideas that I'm now experimenting with and taking into the classroom. One of them is this Ursina Engine. And the Ursina Engine is an open source project, which is basically created by a bunch of people collaborating openly, not for profit, who are trying to make the easiest game engine to use, the easiest way to make games out there. So a game that would typically be like 300 to 500 lines, they're aiming to make it so easy that you can make it in 50 to 100, right? So like 5-6 times, like almost an order of magnitude. So in this program, if you think about making a game that's like playable and decent, I mean, that's something that would take 20, 30 hours. In this program, we actually make like 3 games. So we make a breakout game, which is a famous Atari breakout game. Here, I'm going to demonstrate it in a minute. You're going to find out what that is. And then a collection of games that happen in a 3D world. One of them, you're solving a maze, running around in a randomly generated maze to a goal. Another one is you add the maze into a third dimension where the goal is in the sky and you have to like build blocks and then jump on top of them to get to a target.
So it's becoming progressively more
Yeah, and the kids came up with this concept of having lava come up from underneath because the game where you climb on top of the blocks you generated yourself wasn't exciting enough. So like, I think I'm going to bring up some code and tell you a bit about it. So I guess the first concept I want to cover is this. Everything in a game is an object. And if you can think about like whether it's Pong, where you got like the two paddles, they're objects, the ball's an object, you've got walls.
Yeah.
And in programming, sort of one of the more advanced paradigms, they call it, is object-oriented programming, where basically everything that you use on a computer is programmed using that paradigm, but it's easier to understand, visualize, it's more intuitive in games than anywhere else. So typically object-oriented programming is used and taught somewhere between first and third year of uni.
And you're teaching it to...
And yeah, in this program, we're actually doing it with kids in year 7 to 9. So they're using it. They're not really like, how do I put it? They're not creating classes that build objects, but they're definitely using and modifying objects.
Okay.
And, you know, I'll show you breakout for a second. I mean, we've got, so there's some objects, there's a ceiling, there's some walls, there's a ball and a paddle and a collection of bricks. And you bounce the ball.
Yes, this is looking familiar.
Yeah. You bounce the ball. And by the way, there's some math involved here because you got to figure out the angles at which the ball leaves. And then there's math in figuring out the difficulty and how you can relate the number of remaining bricks and the speed of the ball.
So you can relate it to other learning areas too, right?
Oh, it is. If you're making a game, sort of coordinate geometry is actually a must. Because everything happens in a 2D space or a 3D space. Like the rules by which this ball moves involve equations that have X and Y in them. And so another one would be an equation that figures out, again, how should the difficulty escalate? And so this is sort of a raw version that the kids build. I'm sure it's got a bug or two. Mm-hmm. And I'm also concentrating on trying to break through this wall so I can get above it, because that's the trick, right? You gotta break through the ceiling, and then if you can get it through there, it will wreak havoc. Oh my God, my aim was so good.
Oh, yes. Well done.
Yes.
Fantastic. So Sanjin, if I'm a teacher who wants to use Ursina in the classroom, and I've had experience with, say, block coding programs like Scratch before, how do I make the jump from a block coding program like Scratch to something like a text-based coding program?
That's good. I mean, that is a good question. You really should be looking at some step-by-step resources, which is one of the things I'm going to be sharing in this class. I don't have them preloaded, but like every single, like as I'm teaching this to the students, they're getting PDF handouts. So I drop them over chat in the Zoom, and you have to start again with bits of code. I almost call it like minimum viable product. Like what's the smallest thing you can do? You could draw a square on the screen. What's the next thing you can do? You can have it move across left to right.
Those skills-based sort of stuff.
What is the next one? You can have two objects and they bounce off of each other.
Right.
So like you have to break down what's in a game into easily digestible bits that are 5 to 10 lines of code each. And so it's as if you're like building Lego blocks and giving them to students, which then they can assemble in new innovative combinations that eventually become a game. Okay. So I suppose there's 2 ways to do it. You can learn how to use a platform yourself and then break it down into small digestible bits. That's the sort of first stage of you teaching it.
Yep.
Or you can listen to a podcast like this one and get that delivered to you, right?
Good plug.
Yeah. I think I'm going to show you another one. And this is, by the way, remember how I said games have hundreds of lines? I think the last one had about 60 something. And talk about tangents. So this started off as a game where you go through an obstacle field to find a green target. Then the kids came up with the idea that, hey, like some blocks could be lava. So if I touch a red block, I die. And then someone said, like, why can't we make it rain blocks? And so see this blue thing here is rain. I didn't even know how to make a sky thing, but kids started Googling things. And now we learn how to make sky. By the way, that's me there. I'm a white block. It's very blocky, Ursina.
Right.
So somewhere around here is a, I stepped on a red block, but somewhere in there is a randomly located green square, which is large enough to be seen. So I need to sort of jump on something and find my green square. It's fluorescent. And that's how I win, but it's kind of hard. That's the point. It's not supposed to be easy. So yeah, tell me if you spot a lime green square.
I'm looking, but I can't see anything anywhere just yet. If I wanted to try and use this in the classroom, then what sort of equipment or tech would I need in order to run this with a group of students?
So I'm going to unpack that. Oh, do you see it? I saw it.
No, I just caught a glimpse of it then.
There it is. There it is. So
Yep.
now we're going to win. I'm sorry, like I'm actually.
No, I shouldn't interrupt.
I'm focused. You won.
Focused on the game.
There you go. So the software I'm using is called Funny. Funny is a Python IDE, integrated development environment. It's a little program that you install. The website is funny.org. Funny.org. You can get it for Windows or Mac. It's only like 20 megabytes. And it has one magical feature. If you go here and say manage packages, you can import libraries. Now, libraries are like toolboxes for programs. And the thing about libraries is you typically would need like command prompt and like admin rights on a computer to install one.
Right.
So for example, NumPy, I can search that. And that's like a library for mathematicians to do advanced math with Python. And I can download that with like one click. I can click on it and press upgrade or an install. I've actually already installed it. That's how I know what it is. Typically, that would be very difficult. So just by installing the software, that's the easiest shortcut to that. So for teachers that are looking to teach Python and import libraries and get adventurous with it, Funny is your best bet. Might not be the ideal IDE. I guess go for it.
I mean, at the moment, we're all, many of us actually are stuck at home. So how do you go about teaching this kind of thing online versus in the classroom?
Well, I suppose it depends on which classroom. See, my school is BYOD, which is, what does that mean? The students bring their own device.
Yeah.
So they all have they're going to have different issues with their computers. They all have different levels of access because some of them don't have the final password. And in a sense, in a classroom is sometimes more difficult than online, right? Because if they're online, the admin password, somebody in the house has it. Mom and dad have it, and they're in the house. But if you need the admin password in the classroom, well, you can't really call mom and dad at 2 o'clock on a Tuesday. Yeah. So there's that. If everybody has a device from the school, though, then the IT department, it's simply one email to them saying install this and this, and then you're good to go. So I would say I don't think that the online is a barrier. In fact, I would say it's almost a bit easier because what's interesting is that the computers are getting exponentially more easy to use, that we're at a point where the parents of the kids know how to install software quite often better than the kids themselves. It's particularly if you're talking about kids sort of in the upper primary years.
Yeah, I've certainly learned lots and lots of things off students that they knew way more than I did. In fact, you mentioned that the students had created a game with lava in it.
Oh yeah. That's so like the last one was an obstacle game, and this is another twist on the tail. So right now we've got these blue blocks, and what I was showing them is how we could build blocks, point at it. And they came up with an idea that, okay, why don't we like look for a target in the sky? So somewhere I see it's right there.
Yep.
That's the target in the sky. And now I can build blocks. Unfortunately, I got lava coming out of the ground really quickly, and it's going to get me probably before I can get up to get there, but I'm building like a wonderful, oh no, it got me. So that actual concept is remarkably simple. Lava itself is like one single block with a texture with a speed that's very slowly moving up. And just like we have a collision with the floor, a collision with the walls, the collision with lava is, yeah, an extra 2-3 lines of code. Okay. And pretty much both of the things that you just seen, they were tangents that kids came up with, including this lovely sky that you see out there. Because what's interesting with a library like Ursina is all the documentation is published online. There is more stuff to look up and read than I could possibly read all by myself. And when we have an idea in a class, let's try to do something. I've got 10, 15 young students that are now searching the internet and trying to find the best way to do it. And these programs just evolve over time. I quite simply take the ideas that the first group that did it has, integrate them into the program, and then the next group builds on it and builds on it. And yeah, things evolve in new and mysterious ways. So I really look forward to actually, I'm teaching this tomorrow is the first class of this latest batch.
So Sanjin, why is game design such a great playground for high ability students?
Well, I think there's lots of reasons for that. I mean, by their very nature, making a game is very open-ended because you're going to, as the process goes on and you're troubleshooting, it's an area where like new ideas come up and tangents, and you solve one problem, a new problem pops up. Yeah. So in a way, it's because of the way you're constantly debugging, in a way, it's a mixture of problem solving and open-ended creativity. Now, in an environment that we're doing it, it's like there's somewhere between 6 and 15 of us making a game together. Mm-hmm. And it's constantly reflecting on so here we are, what are the problems that we're having? What's cool about this? How can we make it more interesting? And kids have so much to contribute because like the vast majority of them play games with a lot of their free time. So they intuitively understand what makes a game good, what makes a game interesting. Yep. And in fact, like when I prepare for these programs, the games that I build by myself, despite having a lot more knowledge and skill than any of the students, are way less fun and interesting than what happens after they've all contributed to it. And in that process of like troubleshooting together, them looking up ideas and sending me bits of code, and by the end of it, it's this collaborative thing that we all participate in. It's not so much my game or his game. It's a conglomerate of cool ideas that came up in this sort of game design conversation. So yeah, I think in terms of, a student who's passionate about coding and passionate about games, I don't know if that there isn't too many things that'd be more fun than one of these programs.
And if I wanted to jump into one of these programs, where could I go?
So the website is online.gateways.edu.au. And if you just basically, if you press on this live and interactive thing, these are all the programs that you can enroll in. Now, out of the technology ones, I think, this is the Ursina Engine. We kick off tomorrow. But as you can see, there's different programs, different year levels. I've spotted your name, Jesse, and Sci-Fi with Jesse. So you've been quizzing me about Ursina. So tell me about this.
Yeah, well, we've just added these very recently, actually. So Sci-Spies is part of Clubs Online. So it's an online science club that we're running for 3 weekends. So students can jump in and jump out of different sessions as they please. And we're going to be exploring some different areas of science. So we'll kick off with biology, looking at structural, physiological and behavioral adaptations. And then we're going to jump into thermodynamics. And then lastly, look at a bit of pressure.
Yep. And I wonder like what demos you're gonna do, because I've kept an eye on your Twitter account, and it's a collection of crazy cool home experiments. I imagine there'll be some of that in the program.
Certainly will be. There's a bit of a list there for students to collect before each of the sessions. So lots of hands-on learning. Despite the fact that we're all stuck at home at the moment, I don't think that's any excuse for taking out that hands-on learning. We can keep it in there.
And I mean, look at this. You get the essential stuff, metal teaspoons. I mean, you really, and then the optionals. Like, I feel like dropping in, even though this is for year ones and twos, I could do a bit more science at home.
I'm really looking forward to it.
Excellent.
Really looking forward to it. Well, thank you for joining us, Sanjin. And we look forward to talking with you all again next time. Bye for now.
Bye.